I did my K to 12 schooling in full French, not just French immersion. It was full French, um, and when I was in high school, I did competitive trampoline, and I got to go to competitions in Ontario, BC, Alberta, Nova Scotia, and at a few of the competitions, I had the pleasure to compete in synchronized trampoline with my brother. So I have a twin brother, and a lot of the time people are surprised to know about that. Um, and I'm not lying. He's 1 minute older than me, and no, we cannot talk through telepathy. That's a question I commonly get asked. Before I started with Ingenuity Labs, I had done a an undergraduate degree in computer engineering at Queen's University as well. And as part of my undergraduate degree, I did a 1 year, or I guess it was 15-month internship at a company called Neptech Design Group, and um, they're a space engineering company, and they make vision systems for spacecrafts. They've made a few rover prototypes in the past, so I was working on um, developing software to run on the rovers, um, as well as I was working on a little tiny bit sensor that is meant to go on astronauts and is supposed to monitor their vitals, and it's a mini wearable health sensor. Uh, so I learned a lot during my internship, and before that I was in high school and I did the IB in grade 11 and 12. At the moment, I'm trying to get a robot to make maps of the ground surface without looking. So just by feeling. And what that means is I'm not using any vision sensors like cameras or distance sensors like sonar. Instead, I'm sensing the ground's vibrations through inertial sensors on the vehicle. So that's sensors like accelerometers and gyroscopes. So accelerometers are sensors that can tell us how much the robot is moving up or down, left or right, forward or backwards. Not directly, indirectly, it actually measures accelerations, but you can translate that or do some math to calculate the position from that sensor's readings. And then what a gyroscope is it tells the robot how fast it's rotating, how fast it's turning in all 3 dimensions. So just turning like this, and turning like that. Um, and by doing some fancy math with the data from these sensors and merging it with some GPS, I can make maps of the ground surface vibrations, as well as I can place the location of bumps and potholes on the map. Probably that it's possible to tell which side of a vehicle hit a pothole based only on the vibration measurements. Uh, so no one seems to have done this yet, which is also I found strange. Most people who have been working in this area have been trying to detect whether or not a vehicle hit a pothole, or what kind of pothole the vehicle hit. So being able to tell which side of the vehicle hit the pothole has some pretty interesting and uh, big implications for road surface monitoring. So before, without the side detection, you could say, oh, like there's a pothole on Main Street in the northbound lane, about 10 kilometers from the start. But if we add in that side detection of which side of the vehicle hit the pothole, we can say, oh, there's a pothole on Main Street and then on the right side of the northbound lane at kilometer 10. So by knowing this information, where exactly it's, or more precisely, I guess, where it's located in the lane, we can tell self-driving cars to, for example, keep left when you get near the pothole's location to avoid the pothole completely. This is a bit of a hard question because I don't think I have any one role model. Oftentimes, I'll admire traits in people and strive to be like them. So, for example, I admire my parents' trustworthiness. I admire my supervisor, Josh Marshall's integrity. And I admire my lab mate, Michael's ability to communicate technical concepts in plain English.